Hello and welcome to Coffee Table Physics. I'm Riley.
And I'm Jonathan. The reason you're probably here is because you wondered, just like us, why is glass transparent?
Is it because it's not really a solid, but is more like a liquid?
And so there's more space for the light to pass through?
No. It is true that glass has a strange structure, since it's made by melting and cooling silicon dioxide.
Silicon dioxide is formed when silicon and oxygen react together in the Earth's crust. As they react, the molecules arrange themselves in a regular crystal known as quartz. However, when it is melted, it loses this crystal structure. Then, as it cools and the molecules lose energy, they're not able to move back into the ordered crystal, and so instead form a random structure like that of a liquid.
This liquid-like structure is called an amorphous solid. This gives the glass a uniform surface, meaning it does not scatter the light in different directions. So I can see why saying glass is like liquid is a common explanation, but it's still wrong. Glass is not a liquid, it's a solid. In fact, the real question is why aren't all materials transparent? To understand this, we must go down to the level of the atom.
In an atom, the electrons surround the nucleus at specific energies called energy levels, like a ball sitting on a shelf. The lowest energy shelf is called the ground state. Electrons can move up to a higher shelf if they have enough energy. Otherwise, their energy is too small and they can't quite reach the shelf.
I feel their pain, but luckily, photons of light, if they have the same energy as the difference in energy between the two energy shells, then the electron can absorb the photon and gain its energy. This gives the electron a leg up onto the higher shelf. Unfortunately though, if the energy of the photon is not the same as this difference, then it will just pass straight through, and the electron can't absorb it, and so can't move up.
This is what happens in glass. The energy levels are so far apart that none of the photons of visible light have enough energy to move the electrons up, and so they all pass through unabsorbed. This is why glass is transparent. Well, transparent to visible light.
But not everything passes straight through. Remember the electromagnetic spectrum? There are other types of light. All of those to the right of visible light have a higher frequency, and so they must have higher energy photons than visible light. This is a result of the Planck-Einstein equation. So maybe one of them has not too much energy, but not too little. Their energy is just right.
Well, it turns out that for glass, this Goldilocks region of energies lies in the ultraviolet. This means that ultraviolet photons are absorbed by the electrons and so don't pass through.
This is why you can't catch a tan sitting in a conservatory, just in case you've tried to, as it's these UV photons that cause you to tan. So, if instead our eyes operated in the UV region of the electromagnetic spectrum, then glass would appear completely opaque.
Now, for most materials, their energy levels are separated such that one of the energy differences lies in the visible range. Therefore, the electrons absorb these photons of energy. When the electrons drop back down to the lower energy, they emit the photons of the same energy, and so our eyes detect these photons of a specific colour. This is what gives an opaque object its colour.
And so we reach the end. Now next time you see someone sunbathing in their conservatory, not only do you know that they look a bit silly, but now you know that they're making a big mistake.
Thanks for joining us. If you have any thoughts on the video, feel free to leave them in the comments box.
Plus, tell us if there's something about this wonderful world around us that you think, I want to know what's going on here. We would love to help.
See you here next week.
Same time, same place. Cheerio!